So today is a great day. It's a D-Day. In the moment when we ended tender procedure, public tender procedure, which went extremely well. We have a provider for our gamma beam called the Vega system. And thank you very much for coming here to this short ceremony. We'll sign the contract, and after that we'll have a short statement on each side and a short press conference about if there are questions. So let's sign the...
Thank you.
So, as I said, it's a great day for us. Now, ELIMP is a center in the way we plan to be. We all know that the laser system is working, it's operational, the experimental setups are ready or almost ready for the external users. We'll start experiments with laser system in a couple of months. But due to the unfortunate events which led to the cancellation of the former contract to provide the gamma beam system, Eli was not like a hand without a finger. And now the hand is back, is the whole hand, and I'm sure that in 2022, beginning of 2023, we'll have the system. We're lucky that with Lincoln Technologies, with their extensive experience and expertise in the accelerator-driven light sources, the company is uniquely qualified to build a Vega system. We are extremely pleased to partner with Lincoln and to create one of the premier facilities in the world for nuclear research, for nuclear photonics. So once again, we are very glad that now is no point of return because we signed.
Thank you, Victor. Thank you very much. My name is Michael Fesser. I'm CEO of Lincoln Technologies. And today is a big day for our company. This is the biggest project, the biggest undertaking our company will be doing. And over the next 3 years, we are really happy to work with the folks here, with the ELIMP team, to construct and start operating the world's most powerful gamma ray source ever. And it's actually not just a little bit better. This gamma ray source is orders of magnitudes more powerful than what exists in other places around the world. And our company, this fits right into line with what we have been doing. We have been, over the last 15 years of the company's existence, we have been building X-ray sources which work in very much the same way as the gamma ray source, an electron accelerator coupled with a high power laser system. And now we are extending that and scaling it up for the system here at Eli&P, and we are very confident to be able to deliver on the program in time and on specification to deliver this powerful tool for the European community to perform unique experiments for gamma rays and the interaction with lasers. Thank you very much, and I'm looking forward to working with the team here to realize the project and make it a very big success.
Thank you. So the ceremony is over. If there are questions, please.
Please let me start with Mr. Ruud, the guest here. Could you please elaborate a little bit on the gamma ray facility you are going to build here? Is it just scaling up, or is something new as a concept? I mean, it's a result of some new research you've done on it.
Yeah, actually the gamma ray source that we are going to deliver here and construct fits very well into what we have been working on over the last few years. We are actually in the process of developing a high-powered EUV source for semiconductor manufacturing, and it turns out that a lot of the technology that's needed to scale up and produce electron beams with higher power is completely consistent with this development that we have been doing over the last few years. So this difference of going from X-ray to gamma rays for us is a natural transition, because we have already designed and developed the key technologies necessary for that. So it does not require any fundamental development on our side, because otherwise meeting the challenging timeline of the project, being able to have a working system at the end of 2022, beginning of 2023, would be extremely challenging if there were fundamental research aspects to the system.
And do you expect this kind of equipment to be later maybe multiplied? I mean, is it the beginning of something that will require another such facilities to be built in the future?
So I have to say that our company, this is not the first time we engaged in the idea of building a gamma ray system. In 2007, the US government actually looked into the possibility of building a gamma ray facility similar to that one here, but in the end, it did not receive funding. For us, now that we are really executing on delivering such a powerful system here on site, we are going to look at other opportunities worldwide and see if there's any other research institutes and countries that might be interested in the future building research facilities similar here to Eli&P.
Thank you.
If I may, so I think that everything depends on us. Depends on Linshan, if the machine will be as we all hope to be, and depends on all of us, or my colleagues, that our scientific program will prove to be correct, and will discover, of course, that it's our facility is a research facility. But if the results will be extremely important for the society, as we hope, I'm sure that in that moment will be a lot of other places which will duplicate this system. I mean, we have in our scientific program enough ideas, and if they will become realistic, in that moment the society will ask to have more than this facility, I think.
Academician, please, could you elaborate, could you enlighten us, as we are here in LINP, about why do you need the gamma rays, and what will they add to the lasers you already have?
So the initial idea on extreme light infrastructure, idea which was born 13 years ago in 2006, was to have a center, a research center dedicated to study the interaction of light beams with matter. So extremely powerful laser beam interaction with matter. We as a nuclear physicists, during the competition, which country will host the Eli Center, we came with the idea to use, to have also an extreme light, extreme gamma light, not visible light. And we considered that the idea was correct. Gamma is a kind of light, even if we don't see it. It's, the only difference is 1 million times more energetic than visible light. And our interest is also related to basic science, to study photonuclear reactions, which were, since in the world was not such a system available, the concept of nuclear reaction was not enough studied in the history of nuclear physics. And we know that having such a beam will open new possibility, new research to study the atomic nucleus, the behavior of this system formed by neutrons and protons. During the discussions, of course,